In this video, we are going to have a short tutorial on the reactions of ketones and their test. Don't forget to like and subscribe to the channel after watching so that you will receive every update from this channel. Ketones are basically a class of carbonyl compounds in which carbonyl carbon is bonded to two different carbons. When ketone is added to hydrogen cyanide, the resulting product is called a cyanohydrin. This reaction goes by a nucleophilic addition reaction in which both nucleophile and the electrophile of the compound or the reagent add up to the compound. So in hydrogen cyanide, the cyanide group is the nucleophile and the hydrogen is the electrophile. Always in nucleophilic addition reaction, the electrophile adds to the oxygen and the cyanide, which is the nucleophile, adds to the other bond holding the two compounds, the two atoms. So in here, the hydrogen adds to this oxygen and the cyanide adds to the other component, the pi bond holding the two atoms together. The resulting product is called a cyanohydrin. So this cyanide is from the CN added to the pi bond here, and this hydrogen is from the hydrogen plus added to the oxygen in this compound. When ketones are added to a Grignard reagent, the resulting product is called a tertiary alcohol, and this one also go by the addition of the alkyl portion of the Grignard reagent to the carbon, followed by the acid hydrolysis of the intermediate. So in this compound, the CH3CH2 of the Grignard reagent adds to this carbon, and hydrogen from this water adds to this oxygen to form a tertiary alcohol. So ketones react with Grignard reagent always to form a tertiary alcohol. When ketones are treated with an alkaline solution like sodium hydroxide, the resulting product is called an aldol. This aldol is formed by the doubling of the number of carbons in the ketone compound. So this aldol is a beta hydroxy ketone, which is not really common. Ketones, when added to an alkaline solution of iodine, the resulting product is called an iodoform if the ketone has a free methyl group. So this test is called an iodoform test, and it is used to characterize or differentiate or identify, let's say, a free methyl group in an organic compound. If you have an aldehyde or any organic compound with a free methyl group, when treated with a sodium hydroxide with an iodine, the Ci3, which is an iodoform, is a yellow precipitate, and this yellow precipitate is an identity or used to identify the presence of a free methyl group in an organic compound. So this ketone, like the propanol here, in an iodine solution of an sodium hydroxide in iodine solution, you are going to generate an iodoform, which is a yellow precipitate. When 2,4-dinitrophenylhydrazine is added to a carbonyl compound, the resulting product is called 2,4-dinitrophenylhydrazine. So 2,4-dinitrophenylhydrazine is like this, a benzene ring with a hydrazine and two nitrogen groups. When this reagent is added to a carbonyl compound, the carbonyl group adds the nitrogen to form an enzyme-like complex. This complex too is a yellow precipitate, which is used to characterize the presence of, let's say, a carbonyl compound like carboxylic acids and aldehydes or ketones. So this ketone, in the presence of 2,4-dinitrophenylhydrazine, will form a 2,4-dinitrophenylhydrazine, which is a yellow precipitate used to identify the presence of carbonyl compounds in, let's say, a complex mixture. So this test works for both aldehydes, ketones, let's say carboxylic acid amines, or even esters, because they all have carbonyl groups in them. Take note, ketones are unreactive in a Fehling's solution as well as Toluene's reagent. Now, Fehling's solution is a solution of an alkaline solution of copper sulfate, which is used to reduce a compound to form a complex. An aldehyde has a free hydroxy group, which can reduce the Fehling's solution, the copper 2 plus ion in it, which is blue colored, to a copper 1 plus, which is red colored. Ketones lack free hydrogen atom, so it is unreactive in a Fehling's solution. In the same way, Toluene's reagent, which is a solution of an ammoniacal silver nitrate, also undergo reaction to form a silver mirror if the compound has a free hydrogen in there. Now, ketones lack free hydrogen, therefore cannot undergo a reduction by ammoniacal silver nitrate, which is the Toluene's reagent. So Toluene's reagent, Fehling's reagent cannot be used to test ketones, but they can work best on aldehydes. Iodoform test works best on ketones if they have a free methyl group, and also 2,4-dinitrophenylhydrazine test forms a uroprecipitate with ketones. These ones are used to filter out or used to characterize the presence of ketones or carbonyl compounds in them. But these two, the Fehling's reagent and the Toluene's reagent, works only on aldehydes and not ketones. Thanks for watching. Don't forget to subscribe after watching. Thank you.